Hello students, welcome to Math&Magic. For this video, I'm going to discuss the special products. Special product is a mathematical term in which polynomial factors are multiplied to form products. It is called special because they do not need long solutions. Under special products are square of a binomial, square of a trinomial, sum and difference of two terms, and cube of a binomial. For the square of a binomial, it consists of the square of the first term, twice the product of the first and second terms, and the square of the second term. In symbol, we have the square of quantity a plus b, that is equal to a squared, plus 2ab plus b squared. Another illustration is the square of a minus b equals a squared minus 2ab plus b squared. Also remember that the square of a binomial gives us a perfect square trinomial. For our first example, find the square of quantity x plus 3. What we need to do first is to get the square of the first term, that is x squared, plus twice the product of the first and second terms. So that would be 2 times x times positive 3, or 6x, plus the square of the second term, that is 3 squared. 3 squared is 9. Hence, the square of quantity x plus 3 is x squared plus 6x plus 9. Another example, say we are asked to find the square of 2r minus 3s. First, get the square of the first term, that is the square of 2r, plus twice the product of first and second terms, 2 times quantity 2r, times negative 3s, plus the square of the last term, or the square of negative 3s. Next, evaluate the items. The square of 2r is 4r squared. Positive 2 times 2r is 4r, times negative 3s, that is negative 12rs, plus the square of negative 3s, that is 9s squared. Hence, the product of the square of quantity 2r minus 3s is 4r squared minus 12rs plus 9s squared. Also another example, the square of 4/5 m squared n minus 1/2. Getting the square of the first term, that is the square of 4/5 m squared n, plus twice the product of the first term, 4/5 m squared n times negative 1/2 being the second term, plus the square of the second term, the square of negative 1/2. Evaluating the terms, we have the square of 4/5 is 16 over 25. The square of m squared is m raised to the 4th power, then n squared. Next, 2 times positive 4 over 5 is 8 over 5, times negative 1/2 is negative 4 over 5. Then simply copy m squared n, plus the square of negative 1/2 is positive 1/4. Thus, the square of quantity 4/5 m squared n minus 1/2 is 16 over 25 m raised to the 4th power n squared minus 4/5 of m squared n plus 1/4. Next, for the square of a trinomial, it consists of the square of the first term, the square of the second term, the square of the last term, twice the product of first and second terms, twice the product of first and last terms, and twice the product of second and last terms. As an example, find the square of quantity a plus b minus c. So what we need to do is to get the sum of the squares of the first three terms. We have a squared plus b squared plus the square of quantity negative c, plus twice the product of first and second terms, so that is 2 times a times b, plus twice the product of first and third, that is 2 times a times negative c, plus twice the product of the second and the third term, or the last term. We have plus 2 times quantity b times negative c. Performing the operations, we have a squared plus b squared plus c squared plus 2ab minus 2ac minus 2bc. Another example, Say, find the square of the quantity 2x squared minus 3y plus 2z. Get the square of the first three terms. That is the square of quantity 2x squared plus the square of quantity negative 3y plus the square of 2z plus twice 2x squared times negative 3y plus twice 2x squared times 2z plus twice negative 3y times 2z. Evaluating the items, the square of 2x squared is 4x to the fourth. The square of negative 3y is 9y squared. The square of 2z is 4z squared. Next, 2 times 2x squared is 4x squared times negative 3y. That gives us a product of negative 12x squared y plus 2 times 2x squared, that's 4x squared, times 2z. Product is 8x squared z. And for the last term, twice negative 3y, that is negative 6y, times 2z, that is negative 12yz. Hence, the square of the trinomial 2x squared minus 3y plus 2z is 4x to the fourth plus 9y squared plus 4z squared minus 12x squared y plus 8x squared z minus 12yz. Also another example, say find the square of the trinomial 2/3 m plus 3/4 n plus 1. Repeating the steps presented earlier, get the square of the first three terms. So the square of 2/3 m is 4 over 9m squared plus the square of 3/4 n, that is 9 over 16n squared. The square of 1 is positive 1, so plus 1, plus twice the first term and the second term, plus twice the product of 2/3 m and 3/4 n. That gives us now a value of mn, plus twice the product of 2/3 m and 1, that is 4/3 m, plus 2 times 3/4 n times positive 1 or 3 over 2 n. Hence, the product of this trinomial is 4 over 9m squared plus 9 over 16n squared plus 1 plus mn plus 4/3 m plus 3/2 n. Next, we have the sum and difference of two terms. The product of the sum and the difference of two quantities is a difference of two squares. That is the square of the first term minus the square of the second term. In symbols, using a and b, we have quantity a plus b times quantity a minus b is equal to the square of a minus the square of b. As an example, find the product of the quantities w minus 9 and w plus 9. As mentioned in the steps, we simply need to get the square of the first term, then subtract it by the square of the second term. Square of w is w squared minus the square of 9 is 81. Hence, the product of quantity w minus 9 times w plus 9 is w squared minus 81. Another example, say quantity 2b squared minus c times quantity 2b squared plus c. Doing the same process, get the square of 2b squared, then minus the square of c. The square of 2b squared is 4b to the fourth minus c squared. Also another example, find the product of quantity 2/3 x minus 3/4 y and quantity 2/3 x plus 3/4 y. Get the square of the first term, that is the square of 2/3 x, or 4 over 9x squared, then minus the square of 3/4 y is the same as 9 over 16y squared. Hence, the product is 4x squared over 9 minus 9y squared over 16. Last, for the special product, we have the cube of a binomial. To find the cube of a binomial, we first need to get the cube of the first term, thrice the product of the square of the first term and the second term, thrice the product of the first term and square of the second term, and cube the second term. As an example, say find the cube of quantity x plus z. Following the steps, we need to get the cube of the first term, that is x cubed, plus thrice the product of the square of the first term times the second term. So that would be 3x squared times z plus thrice the product of the first term and square of the second term. That is 3 times x times z squared plus the cube of the second term, or plus z cube. Evaluating the item, we have x cubed plus 3x squared z plus 3xz squared plus z cubed. Another example, find the cube of quantity 2x minus 3y. Following the steps, get the cube of the first term. So the cube of quantity 2x is 8x cubed. Next, thrice the product of the square of the first term and the second term. So 3 times the square of 2x times negative 3y. That is 3 times positive 4x squared or 12x squared times negative 3y or negative 36x squared y plus thrice the product of the first term and the square of the second term. So that is 3 times 2x times the square of negative 3y. The square of negative 3y is 9y squared times 3, that is 27y squared, times 2x, that is positive 54xy squared. Then the cube of negative 3y is negative 27y cubed. Hence, the cube of the binomial 2x minus 3y is 8x cubed minus 36x squared y plus 54xy squared minus 27y cubed. Thank you for watching. Please do not forget to like, share, and subscribe. God bless.